Welcome to our next installment on how things work, and today we're going to be taking you through the functions of the battery and the alternator in your car. Now, a lot of people ask, what is it that actually supplies the electrical current to the vehicle? Is it the battery or is it the alternator? And it's actually a bit of both, but it just depends on when we're using each of these. So when we first start the car, naturally that's when we're using the battery. So the battery is what cranks the engine. But once the engine's up and running, actually a lot of the power that is supplied to the electrical system in the vehicle comes from the alternator. Now when we start to use heavier and heavier consumables like our infotainment systems and the like, then obviously we start to use some of the electricity from the battery itself. So it's a bit of give and take, but ultimately most of it comes from the alternator. Now the reason why I bring that up is because quite a few times when our battery packs up or when our alternator packs up, it's very difficult for us to diagnose it, and we go out and we spend a lot of money on a new battery when actually it was the alternator or vice versa. So I wanted to take you through a few basic diagnostic steps that you can have a look at. So first things first, if you start the vehicle and it battles to crank over the engine, well, the likelihood is that it's the battery that's at fault. However, if the vehicle is started properly and now you're driving it, and for example you're driving at night and you start to notice that your headlights are dimming or some of the other functions on the car are not working properly, well then it's likely that it's the alternator that's at fault. Now there's a few basic steps that you can do to save yourselves a lot of money if you are starting to experience those symptoms. The first is to simply take your vehicle into your local battery shop and have them do what's called a load test on the battery. So they apply a lot of load on the battery and they can get a reading on whether the battery is at fault or not. If you've ticked that off, then unfortunately it's going to be the alternator. Now there's another thing that causes batteries to go flat often, and that is the tracking devices that we have on our vehicles. Now you may not know this, but when your vehicle is switched off, the battery is still being used. We call this a quiescent current draw, and it's normally at about 0.75 amps of draw, and that's just keeping up your control units and charging those little batteries in the control units. But when you stick some advanced tracking device to your vehicle, we can actually ramp up the current, the quiescent current draw, to about 1.75 amps, and in that instance your battery is going to run flat very, very quickly. It'll be a matter of days if you haven't used the car. So one of the big things to look at is what tracking device you've got on your vehicle if you're constantly having battery problems. All right, so let's have a look at the battery that we currently find in our vehicles and what sort of maintenance that we have to do to make sure that the battery lasts as long as possible. So in the past, you will remember that we had to maintain the levels of our electrolytes in the battery. Well, these days we don't have to. The batteries are fully sealed and therefore maintenance free. So the only bit of maintenance that we really have to do is if our battery goes flat. So most of us have trickle chargers at home that we stick onto the battery to charge it up. Just a bit of a caution over here, don't overcharge the battery for an extended period of time. My rule of thumb is don't go more than 8 hours, and the reason for that is that when you're putting in a whole lot of energy into the battery to charge it, we're creating a lot of heat and we're creating a lot of gaseous discharge. And between those two things, we put the battery at risk of exploding, and that's a place that we don't want to go down. Now, the reality is that if you're having to charge your battery for longer than 8 hours, it's probably time to get a new battery. Now, the interesting thing with batteries in modern vehicles is that currently they are 12-volt batteries. However, that's changing, and it's changing rapidly. And the reason for that is that we're starting to see new technologies appearing in the vehicles, from soft hybrids through to the immense number of control units and computers that we're seeing and other electronic components in the vehicle. 12 volts is simply not enough. So we're going to start seeing vehicles, and we already are, with 48-volt batteries. So how long can we expect an average battery to last in a vehicle? Well, all things being equal and under normal operating conditions, we're probably going to get about 4 years lifespan out of a battery. Right, now let's have a look at the alternator. As you can see, the alternator is driven via a belt which is connected directly to the engine over here. And the reason why I highlight that is because an alternator actually consumes a lot of power from the engine. Anything from 2 to 10 kilowatts actually, depending on the size of the alternator that you have in your vehicle. Now, the importance of that is that there's a lot of work that's been done around the design of alternators to make them less power hungry from the motor itself. So we know that an air conditioning compressor can actually detach its pulley to save a bit of power being consumed by the engine and therefore fuel. And we're now starting to see alternators that have the same ability, where they're actually able to disconnect when they're not in use. Now, another design consideration when it comes to alternators is, of course, cost. These are very, very expensive items to make. And one of the most expensive areas is actually in the winding of the wiring in the alternator itself. So I'm going to show you the two main ways that we wind an alternator. The first is in a star configuration, and the second is in a delta configuration. Now, I'm not going to take you through the engineering behind this. Really, one of the reasons why I wanted to show you this is because the most common way that we wind an alternator is using the star configuration. And what's very cool for me is that it actually represents the flux capacitor on Back to the Future. But nonetheless, this is a much cheaper alternative in terms of how to wind an alternator. We get the most current out of this. And the second thing that's important is that it's very easy to create a neutral point out of this. So just one of the design philosophies behind a modern alternator. Another focus area in the design of the alternator is how we eradicate heat. Believe it or not, there's a lot of energy going through the alternator which generates a tremendous amount of heat. Now, on older alternators, you would have noticed that there was quite a basic fan that was at the back of the alternator that we used to cool the alternator. These days, a modern alternator actually has two sets of cooling fans that are internal, and in fact, there are some vehicles where the alternators are indeed water-cooled. Now, the alternator, as we know it, is about to come to its useful life's end. And the reason for that is that these days, particularly with soft hybrids, we are now starting to see integrated alternators and starter motors. And let me show you how these work over here. So what you'll see is there's no longer an alternator on the side of the engine that's driven by a pulley. The integrated alternator and starter motor is actually between the engine and the gearbox, and those serve two useful functions. So we have a 48-volt battery over here, and when the vehicle comes to a stop, everything switches off. The battery still continues to supply power to all your electronic consumables on the vehicle, but as we pull off, what happens now is that the starter motor gives the engine a little bit of an assist when it pulls off. And in fact, it doesn't stop there. So when you start to accelerate a little bit harder, if there's enough power charged in the battery, this alternator will then give the engine another little bit of assist. And in fact, what we've seen here is that we can reduce the size of V8 motors down to V6s and still have the same performance on a normally aspirated engine. The other cool thing with this technology is the regeneration properties out of this. So when your foot is off the accelerator, what happens now is the engine converts the starter motor into an alternator, which then recharges this battery over here, and then that loop continues. So exciting stuff to come, and in fact, in future episodes of How Things Work, we're going to talk about hybrids and all the various types of hybrids. So be sure to look out for one of those episodes, and until next time, see you again.